This tutorial is going to show how to take a mesh like the one you see on the screen now and using geometry script create a snow topper object that conforms to that mesh and works well with systems like Nanite. So rather than using tessellation, this uses pure geometry and it's created using a geometry script. This video will be split into two parts. First part will cover the basics of geometry script and how to create a sort of more basic version of what you see on the screen now. Part 2 will expand upon what you created in part 1, adding more features and more details to allow you to create something that's a bit more complex. Unfortunately, due to work commitments, I'm only going to be able to upload part 1 for now, but if you hit the subscribe button, hopefully you'll be notified when part 2 is added. I would like to add that I'm by no means an expert in geometry script. This was actually the first geometry script I ever created. There's some great tutorials already available online. One of the ones which I used was one by Schmidt. As far as I'm aware, Ryan is part of the team at Epic that created the Unreal modelling tools. Ryan's videos are bite-sized and a great resource. I'll try to put a link on the screen and in the description, so definitely check them out. This video will cover a lot of the ground that he covers. The only reason that I've done that is just so that there's like a self-contained video that has all the steps in order to create something like what you see on screen now. Before you can start making any geometry script based objects, you need to enable the plugin. To do that, you go up to Edit, Plugins, and then search for Geometry. And in your list you should see a geometry script. It's an experimental feature, so you need to bear that in mind. So I'm going to click yes to enable that, and then you'll need to restart the editor. Once the editor is restarted, the first thing that we need to do is actually create a new blueprint that we will use to create our geometry script. So what we do is go to the content drawer, right click, go blueprints, and then I want to add a new blueprint class. What you'll need to do in order for this geometry script to work is you need to go down to all classes. So you want to search for generated dynamic mesh actor. So you select that, give it a name, and open it up. Once you've created your blueprint, go into the event graph. Inside the event graph is where you're going to create all your geometry node scripting. So in order to add a node, we need to right click. Now geometry script requires this event called onRebuildGenerateDMesh, and this is basically where all of your geometry script will be ran from. And once we have the node, we can start creating our geometry script. But before I do that, let's just do a really basic thing. And if you've watched any of Ryan's tutorials, as I mentioned earlier, you'll have seen him do the same thing. So I'm not going to go into this in much detail because he has way better videos. So if you drag off here and then click append, then you can see that you can append this with a whole bunch of different objects as a starting point. But just for the sake of this particular demonstration, I'm just going to use the curved stairs. So once I've added that, and then go to my content drawer and drag this into the scene, and then all I need to do to get this to show is to recompile. So if you click up here, that will recompile everything that's in your scene, and now you can see we have a set of stairs, which is very cool. Obviously we can make edits to this, so say we go to 200 and then recompile. Now they're twice the width they were before, or if we want the steps to be very sillily large, then we can also do that too. Obviously if you created variables, then you could edit these on the fly rather than having to recompile every time. As I say, if you want more details, then I'd highly recommend watching Ryan's videos on YouTube. So as I said at the start of the video, I'm really new to the geometry scripting in Unreal 5, but my basic understanding is that the target mesh is effectively the final mesh that you're going to end up with. To make things easier, what I'm going to do is promote this to a variable. If it is a possible variable type, then if you right click any pin, you can promote it to a variable. So once I've done that, I've got a variable that says target mesh. This just makes it easier for me to reference it later on inside my graph. So as I just said, the target mesh will be like your final mesh, but if you say want to have your target mesh be a sphere, but then you want to subtract another sphere from that sphere, like a Boolean operation, then you need another mesh. You can't just do it with one mesh. So in order to do that inside geometry script, what you can use is a thing called an allocate compute mesh, which is a temporary mesh inside Unreal that allows you to use that in your various geometry script operations. So I'm just going to create one of those now. So if I drag my pin off and go allocate compute mesh and select that. What this is going to do is it's going to have one mesh, which is my target mesh, and another mesh, which is this allocate compute mesh. Now, neither of these have any information in them at the moment, but these are being set up so that we can add information into these. I'm also going to promote this to a variable. I'm going to call this Raycast mesh actors. I'll explain more about the raycasting and everything later on, but for now that's what we're going to call it. But we do actually want to add a variable, and what we're going to do is we're going to add a variable that will allow us to add objects in our scene into this particular blueprint. So let's click a plus. We're going to name this meshes to add snow to. So basically meshes to add snow to. So now that we've added that variable, you'll notice that it's defaulted to a boolean. We don't want to use a boolean, so we are going to search for an actor, which is basically any object inside Unreal. You could change this to be more specific, like maybe a static mesh actor, like this. But for the sake of this demonstration, I'm just going to make a root actor, which is maybe a little bit messy, but it will do for this. So now we have static meshes to add snow to, and we've got the type is set to actor. So once we've added our variable, I'm going to expose that variable so that we can edit inside the editor, and I'm going to compile. I'm going to minimize this. Now if we go to the outliner and make sure we've got our snow generator selected, then go to the details panel, we'll see that there's a new variable that we can edit in here called meshes to add snow to. So first thing I'm going to do is just drop in a simple sphere. So let's drop that in and move it up. And then if I go to our details panel and select, our outliner, select the snow generator, then the details panel, and then we can use this eyedropper. If we click this and then click on it, we will add, I'm going to pin this, we will add the sphere to our mesh. So now that means that inside our blueprint we have access to this sphere. And what we're going to do is something really simple, which is basically copy that sphere into our target mesh. So to do that, what we will do is we will go copy mesh from component. So there's lots of different versions, copy mesh from static mesh, etc. But we're going to use the component one just because we're using the actor rather than a static mesh. So copy mesh from component, and then what we're going to do is get our variable. So if you want to get a variable at any point, you can drag it into the blueprint editor and then say get the variable, which is the get meshes. So once we've got this, we can go to the root component, because a static mesh root component is the static mesh component, and we want to copy a component, so let's do that. So I'm just going to do this and I'll show you what it does. We need to connect this to the component because that's what this is, it's the component part. And then what we want to do is assign it to our dynamic mesh. Now we can do this to either the Raycast mesh actors or the target mesh, but for this example I'll just put it into the dynamic mesh to target mesh. Now what this node is going to do is basically take the mesh that we've selected, in our case the sphere, and it's going to copy it to our target mesh, which is our geometry script mesh that we're generating. If I leave it like this, and then I'll move this over to the side so you can see. So currently we have our snow generator selected, but we don't have anything. Why is that? Because we've not compiled our blueprint. So once we compile our blueprint, what I'd expect to see is a sphere here. So there we go. Now our generated mesh is basically taken this object and copied it over here. So if I was to go into the place actors and then place a different type of actor, like a cylinder, and then go into our snow generator and then meshes to add snow to, and then select the cylinder, you can see that that now changes it over to cylinder. Now if I select the sphere again, it'll change it to sphere, because it's basically taking that variable, which is the meshes to add snow to, which we've got here, which is a sphere, and it's copying that to this target mesh, and the target mesh is our geometry script mesh. Say for example we want to place a sphere on top of our geometry script mesh. So we've created our geometry script mesh, which is currently a sphere. Say we wanted to put a little sphere on top of that geometry mesh. Now there's lots of ways you could do that, but if you want to have lots of spheres like placed on top of this target mesh, then it might be worth using a feature called a bounding volume hierarchy. It sounds complicated, but basically all it is a representation of any mesh in a efficient way that the geometry script can use that and do calculations on it. Now, if you were just to do these on the actual meshes themselves, then it would be a lot slower, whereas the bounding volume hierarchy just allows these computations to be faster. But in order to tidy things up a little, what I'm going to do is create a sequence. Now, if you've never used a sequence before, when this command executes, then everything to the right of that gets executed. So it first does this, then it'll do this, then it'll do this, then this, then this, then this, and that is like a linear process. Now you could continue like dragging off here and adding more and more nodes, but if you do that, you end up with these really long node graphs that go all the way off to the right hand side. So in order to just make that easier, you can use a sequence, and what that does is it means when it's finished this, it will then run on to this next pin. So once I drag off this, if I type build, and you'll see that what comes up here is the BVH for mesh, which is the bounding volume hierarchy. So basically we're going to add one of these. Again, I'm going to promote this to a variable. If you were to connect this, as Ryan says in his video, directly into various computational nodes, then it will keep rebuilding this mesh, bounding volume hierarchy mesh every time. Whereas if you put it into a variable, then it will just use the one you've generated. Now, before we move ahead, I'm just going to quickly tidy up a few things. The first thing is here is if there is no mesh assigned to our meshes to add to no variable, then we'll get an error because it's trying to copy a component from something that does not exist. In order to solve that, what we can do is select our variable, right click, and convert it to validated get. Now, all that means is that it will check to make sure that this actually has information in it, like it has an object assigned to it. Connect that in on one side, and then you basically say it is valid. Then we can go on and try and do this copy from component. I also want to change this from the target mesh to this mesh recast actors, because I don't want it to go this thing to be copied into the target mesh. I want it to be copied into this cast mesh actors, which I will explain in shortly. So I'm going to swap this over, and then I'm going to move this target mesh out of the way. So now what we'll have, if I go back to our editor, open this, and then I'll select, let's do the cylinder, and then I'll compile, and you'll notice that it disappears. Now that's intentional because we're no longer allocating it to our target mesh. It's now in this Raycast mesh actors. And as I said at the beginning, the only thing which Geometry Script is going to show you currently is the target mesh. And seeing as that variable is not used at the moment, it's not really going to show you anything in the editor, but behind the scenes, this Raycast mesh actors is going to now be a cylinder like this. So now if we take this Raycast mesh actor and also assign it to the bounding volume hierarchy, then that will mean that the bounding volume hierarchy variable will now contain that cylinder also. So what we're going to do next is use a Raycast to be able to find a position on our object to add a sphere. To do that, what we do is we search for find nearest ray intersection with mesh. Now what that basically is saying is it's going to find the nearest point on the mesh where our ray intersects. We can connect that up, and then our mesh that we're going to test against is going to be the Raycast mesh actors. So we connect that up also. And then we're going to connect in this output BVH. We can just drag it in like that, or you can go over here and then get the variable, and seeing as we're going to be using the variable reasonably regularly, we will do it that way. If you select everything and press Q, then it will tidy everything up for you. Okay, so now we've got our mesh and we've got our bounding volume, which is just going to help speed this calculation up. What we need to do is define the direction and starting point of our ray. So to do this, what I'm going to use is our target mesh, which is our ray mesh actors, and I'm going to get the bounding box of it. I'll explain what the bounds is in just a moment, but before we do that, let's split the split pin. Now you can see we've got a minimum and maximum. Okay, what on earth is bounds? So if you go into the editor and then go show, advanced, and then select bounds, and then click any object, you can see the bounds of an object, and it's this red box. So the bounds is literally just the extents of an object. So we know that the minimum bound and the maximum bound, if we add these two together, and then if we divide that by 2, With Unreal 5, when you do divide, you have to right click and then decide what type you want the second pin to be. So in my case, we'd like it to be a float. So this is a vector, yellows are vector and greens are floats, or light greens are floats. And we're going to divide this by 2, which is going to give us the center point of our bounding box, the point right in the very middle of that red bounding box we saw before. Now we're not quite done yet, and we need to move this starting point up so that it's above the sphere, and we're going to cast down. So what I'm going to do is right click and split this. I'm going to also split the ray origin, and I'm going to connect the X into the X, the Y into the Y, because X and Y we want to be the center, but the Z I want to basically add an offset. So I want to push, so if you imagine our sphere, our X and Y, let's do it this way. So our X is across the way, Y is this way, so we've basically taken the center point of that, but for the Z, which is up, we want, it's going to currently be here, but we want to move it up so it's above this object, and then we're going to fire a ray down onto this object. So to do that, what we do is we basically take the Z, and then we add a number. So let's just say, for argument's sake, we'll do 100 meters, which is ridiculous, and you shouldn't do numbers higher than they need to be, but just for this example, it's fine. And we'll put that into the Z origin. So that means that we now have a point that is in the middle of the sphere, but 100 meters up in the sky, way up here. And then we're going to put a ray direction on -1, which basically means that it's firing directly downwards. So this is quite nice. It basically decides whether it's found a point or not found a point. So we don't want to do anything unless it finds a point. So we can drag off here, and what we're going to do is an append, and we're going to do an append sphere box, which is basically a sphere, and then we're going to drop in our target mesh, get, and assign that to our mesh, so it's going to create a sphere on our target mesh. And then we need to split the hit results. So when our ray comes down, so the ray's up here and it fires downwards and hits our sphere, when it hits our sphere, it's going to populate all these variables. So you've got hit position, you know, the mesh, all sorts. But the only thing we're really interested in is the hit position, which will be the point on the sphere where it hits. So we're going to break this transform as well, split the strut, and we're going to put the point into the location. And everything else can pretty much stay the same. Obviously, we can change the size of the sphere and the amount of subdivisions it has and everything like that. But for the purpose of this, let's try that and see what happens. So what I'd expect to see if I select our snow generator, which is here, I'd expect to see a sphere appear here, as if there's another sphere underneath, but there won't be another sphere, and I'll explain why in a minute. So compile, yeah, and you see we've got this sphere. Now if we were to go into our thing and make this a bit smaller because it's a bit big, make it like 5 instead, and then compile, you see we've got a sphere right on the top of our invisible cylinder. Now you might be adding, where is the cylinder? Now, well, let's go back and explain why we don't have a cylinder. So basically, the reason we don't have one is because our cylinder is currently assigned to this mesh, Raycast mesh actors. It's not assigned to our target mesh. So if we want to have both the Raycast mesh actor and the target mesh, then we need to append this mesh to the target mesh. So in order to do that, do you know how we talked about earlier about the copy mesh to component? Well, I said that we'd probably use another version, and we will do that now. So basically what we're going to do is if we take our Raycast mesh actors, which has got our cylinder in it, so we drag off here and look for copy. So if we look for copy, then we'll see a mesh to mesh. Now this basically will copy the mesh from this object into any other object. In this case, it's going to be our target mesh. So we'll do that, and then we'll connect this up, and then we will connect up our target mesh. Yeah, so basically what we've done now is we've taken the ray mesh actor and we've copied it into the target mesh actor. So that will give us our cylinder. Now we need to actually append the sphere to that target mesh too. So we can connect this append sphere into here and then compile. And what we should see now is we have a cylinder with a sphere on top. Now the cool thing about this is if we were to then select the sphere, we'll have a sphere with a sphere on top. We select our snow generator, click that, and then click the plane. You'll see that it's not just, you know, placing a sphere in the middle of nowhere. It's actually raycasting down onto this plane and then placing that sphere. So in order to create multiple raycasts, what we're going to do is use a loop. To add a loop, you just right click, go for loop, and what we want to do is add a for loop. Now it's really straightforward. You have an index and it will go from the first index to the last index. So in this case, let's just make it easy and put in a number of 10. So basically what's going to happen is it's going to actually produce 11 outputs, because you're going to have 0, then 1, 2, 3, and all the way up to 10. So you wanted 10, you'd make this 9. So let's do that for now. So this is just going to loop through this 10 times. So our loop body is going to be our raycast. So all that will do at the moment is raycast that same ray which points from the center of this plane currently, fire a ray down 10 times, and we're going to have 10 spheres on top of each other. And you're not going to see anything different to what we have now. So in order to make that not cast directly down in the same position, what we're going to use is a random float in range. Now I'm just going to copy and paste this in because it'll save some time. So random float in range does exactly what you think it would, which is it basically takes a minimum and a maximum float and it gives you a random number. We've got our bounding box here. I'm going to get rid of this because we don't need this anymore. I'm going to split these strut pins so I can see individual axes. So this is the X minimum, this is X maximum. So what we want to do is get a position between the X minimum and the X maximum, and then I'm going to put that into the X, and then we're going to get a position between the Y minimum and the Y maximum. I'm going to put that into the Y. And for the Z axis, we're just going to take the maximum Z away from, i.e. subtract it from the minimum Z, and then we're just going to add an offset on this value. So it's going to take the height of the bounding box in the Z and it's going to add it on a whole bunch of extra units. I'm going to reduce this because 100 meters is far too much. 10 is still a lot, but it's better. It means the ray doesn't have to cast as far, and the longer the ray length, the more time it takes to process the ray cast. Now what we've got is a random value in X, a random value in Y, and a fixed value in Z. So now that we've done that, we should be able to just compile and see that happen. Okay, cool. So we get an error. Now this is just simply that the stream, which is this, it's basically like a seed if you've used any random values before. Generally a seed is just a way to reproduce that random value. So if we right click on here and just promote this to a variable, then we get stream, and we can do the same for this. Click compile, and now we get our object. Now you'll notice that it only created one sphere still. So the reason we're getting this issue is really straightforward. Because we're looping around this 10 times and it's going into our raycast, and then we're copying that mesh every time this gets called, and then it will try to append a sphere to it, which will ultimately mean that we end up with just one plane and a sphere. So to fix this, it's really straightforward. We connect the raycast to the actual append sphere, and we move this copy mesh to before our for loop, because we don't want to copy this 10 times, we only need one of them. Now if I move this out of the way and compile, what we end up with is our random spheres and our plane. So that's exactly what we wanted. And the cool thing is, if we are to select something else, then we will get random spheres on a sphere, or on a cylinder, or on a cone. One of the problems that we've got at the moment is currently our snow generator is generating our snow, which is going to be these little spheres, in local space, i.e. it's basically generating the snow around the local pivot point of the snow generator. We don't really want that, because if we have a scene and we have these cylinders, imagine the cylinder was a car, and we wanted snow to be placed on the car. We don't want to have to generate the snow at origin or wherever the snow generator is, and then have to move this object to replace this cylinder or car. We want the snow just to be generated on the cylinder. So to fix this, what we're going to have to do is do some local to world transforms. This is a little bit complicated in terms of understanding how it works, but you know, if you think about it a bit like when you're moving 3D objects in a world, you have like local transform when it moves on the axes of the independent object, and you have world transform, which is when it moves the object in relation to the world. So it's a little bit like that. I'm just going to show you how we set this up. So the first thing we want to do is we want to click this transform to world, and that will mean that when we copy the mesh to this Raycast mesh actors, the actual mesh will be in the correct position. Then what we need to do is transform the mesh. What we're going to do is get actor transform, and then we're going to invert the transform, and then we're going to connect that in. I'm just going to connect this up, and you can copy it and it will do what we need. Now that we have the transform being sort of converted, we will end up with our object in the correct place, as you can see now. So you can see that we have our spheres now attached to this cylinder, sorry, this cone. Now if we select our mesh and then select the cylinder, you'll see the spheres go onto the cylinder, and we select the sphere, it goes on the sphere, we select the plane, it goes onto the plane. So that's what that does, and it really makes this a lot easier for moving forward with this. Now that it's doing that, we no longer need to copy the mesh, because we don't really want a copy of this plane. If you had a car and you want it slow on top, you don't want the car twice, you only want the car once. So we can remove this copy to mesh section, we don't need that anymore, and just connect this up straight away, and then go compile. And now what we'll do is we will have just this single plane. Now to make this even more interesting, what we can do is we can go to our meshes to add to snow, and then if we go over here, basically this allows you to change it from a single to an array. Now what an array is a list of objects rather than a single object. So if we click array, I'll show you what it does. It's going to kick up some issues because we're changing the variable type and we've used this variable. So now it's going to be like, hey, wait a minute, you're trying to change this, it's not going to work. So we'll just allow it to happen, and then it will come up with a bunch of errors. So you can see here it's broken our execution because this no longer works, because this is no longer a single variable. So basically we want to break the links, and now we've got this version of our meshes to add. But before we go any further, I'm just going to show you what this allows us to do. So if you look in our snow generator, we've got this meshes to add snow to, and we've got like this plus button. Now if you click plus, we can now add multiple objects to our snow, generator. However, you'll notice nothing's happening, and that is because we've not connected this up properly. So unlike before where we just had one mesh, we now have potentially hundreds or thousands of meshes if we wanted to inside this array. So what we need to do is loop again. We need to loop through each version of those meshes and then do an operation on it. So what we're going to do is go for, and you want a for each loop. So basically all this loop does, unlike this loop where you assign like a number of loops that it's going to do, this will do the number of loops based on how many objects are in this meshes to add variable. So it just means it's, in our case we currently have 3, so it means it will loop 3 times. We'll connect this up, and then out of the loop is the array element. Now this is the individual objects. The array element will be like a sphere, then it'll be a cylinder, then it'll be a plane. So currently we connect that to here. It's going to take this sphere, cylinder and plane, and it's going to copy it into this mesh actors, which is exactly what we want it to do. Now you'll notice that that didn't really work, and the reason why this doesn't work is why we have allocate commute meshes. We basically need to create another allocate compute mesh. So what this is doing is it's going to the first object. So this comes in, this variable comes into this loop, and it gets the first one, which is a sphere, and it goes, cool, we want to copy that sphere to our Raycast mesh actors variable. So it copies the sphere to Raycast mesh actors variable, and that's like, great. Then it comes into the loop again with the cylinder, and it goes, oh cool, I'll copy that to the Raycast mesh actors, but it doesn't add it, it copies it, so it replaces the sphere. So each time it goes down the list, it replaces what already exists, and we don't want that. We want to add it to what exists. So in order for us to do that, we need to have another compute mesh. So we go compute, and we want to allocate compute mesh like this, and then we want to connect this into the dynamic mesh. So now each time it comes into this loop, it's going to create a compute mesh, and then it's going to copy that variable, so in this case a sphere, it's going to copy that to the compute mesh. And then what we can do is we can append a mesh. So on success, we go append for mesh. So here is append mesh, and we're going to put the target mesh as being our Raycast mesh actors. So it's going to basically, this is what we're going to add these meshes to. And then the append mesh is what we want to add. So we're going to add whatever this sphere is. So currently what's happening is as each of our variables meshes are put into our for loop, and then we allocate our compute mesh, which basically takes on that object, and then we assign that object to our Raycast mesh actors. Each time this loop goes, we're creating a new compute mesh. Now, if we don't release these compute meshes, they're going to build up in memory, and then probably after a while crash the editor. Certainly make it start running slowly. In order to fix this, what we need to do is release these compute meshes after they're created. So to do that, we basically right click. Now you can choose to release all compute meshes, but if you choose that, it won't work. And the reason for that is because we need a compute mesh, because we're using a compute mesh for these Raycast mesh actors. So if we remove all compute meshes, we'll also remove this. So we don't want to do that. What we want to do is right click and type release compute mesh. So rather than release all compute meshes, we're just going to release a single compute mesh, which is this one, and then we're going to do it on failure, because if for some reason we generate a compute mesh and this doesn't copy to the component correctly, like if it's not a static mesh, then we still need to release this because you don't want it sitting around in memory. And we also want to do it on success, so when it goes through on success, we want to release it, and when we go on failure, we want to release it. And then all we need to do is connect the compute mesh to this release compute mesh. Now, just to make it a bit easier, I'm going to double click to add a reroute node. This just is basically to make it look a little easier to read. So what happens is the allocate compute mesh copies the mesh component, then we assign that to our Raycast mesh actors, and then we release that compute mesh, so it's not kept in memory anymore or any longer than we need it. So once we compile this, what we should see is a bunch of spheres appearing onto our objects, which is great, it's working. You'll notice that there's more than 10, and that is because I changed the variable to 50. And you're like, wait a minute, you only counted like 13 or 14. Okay, so this is the next thing we need to understand, and this could be done in a different way to make it much more efficient, but for the sake of this video and time, we're going to keep it this way. But what is happening is we're taking a bounding box now of all of these objects. So when we showed the bounding boxes before, let's show the bounds, and we select one, we get the bound for that box, and we get another bound, and we get another bound. But if you imagine we had all of these selected, then although it's shown individual bounds for each of these, in our case our bounds would be the bounds of the edges of all of these objects. So the bounds is huge. It's like, you know, 4 squares by 4 squares. It's going to create a huge bound. So when we do our random raycast coming down, some of them are going to miss. They're not going to hit these objects because the bounds is bigger than these objects, and it's going to go in these gaps. And that is why we end up with only, 14 out of 50 raycasts. Now that is really inefficient, and you could definitely do better process to make this more aligned to just those individual meshes. Fundamentally, for the sake of time and the ease of explanation, I'm not going to do that. So now let us promote this to a variable. So right click, promote to variable, and we're going to call this number of spheres for now, and then we're going to make that visible inside the editor, and we're going to compile. Now what happens when we go into our object, so we select one of our spheres and then go down here and set this to 10, then we get 10, in this case too, it was set to 500, we get 500 of these. And let's just add in the cylinder as well, so we can click here, and I'm going to move the cylinder up, and then just so that we end up with things being a little bit more efficient, I'm going to just move all of these a little bit closer together, because it will save us having to write a whole bunch of code. And it also shows a problem that when you move objects, these don't update. Now you can set up something that will force an update. Again, for this, if you look at Ryan's videos, it'll explain how you can do that. you can just change a variable and it will update what has happened. Now you can see there's a lot more objects being added instantly. We basically have our snow now. Now you could put this up to like 2000 and you effectively have something that kind of looks like snow. You'll notice that it's not, because our rays are coming straight down, it hits the sphere, and because the ray is then finished, it doesn't create one underneath the sphere. So you get this kind of nice shadowing effect, and you could change this if you don't want that to happen or do want it to happen, etc. But for now we're going to keep that. So as you saw, we have our spheres being generated, which will be our snow. But how do we make this look more like snow? It doesn't look very like snow at the moment, so let's fix that. So what I'm going to do is add another sequence, and then I'm going to drag off that sequence, and I'm going to create a branch. Now what a branch does is like an if statement, so it basically goes, if this is true, then do this, if it's false, then do this. So I'm going to right click here and go to promote to variable, and then I'm going to call this remesh. So basically we're going to have this variable which is going to be visible inside our, I need to compile. It's going to be visible inside our snow. There it's there, remesh. And if we tick it, what we want it to do is we want it to do a remesh. So we go remesh or voxel. There you go. So it's called voxel, remesh, voxel. They're often sort of both used. Anyway, we're going to use this morphology version, and then we are going to make our target mesh our target mesh. And we want to be able to see these options, so I'm going to split the strut pin, and then I'm also going to split both these ones, so I want to see all of the options. I'm going to leave it default for now, but we will set these up to be variables shortly, and then I'm just going to compile. Now when we come out, what we get is something that kind of starts to look like snow. Now you can see it's kind of broken looking at the moment, and we will fix that. But just to show what that boolean did, let me just put it on the screen. So this boolean here basically goes, do we want to remesh or do we not want to remesh? So if I click the remesh, then we get the spheres because it's not remeshing. And if we want to remesh, then we get this sort of more gelatinous blob. It's kind of like a metaball if you've ever used metaballs before. Anyways, the next thing we'd like to do is be able to make these a bit thicker. Now, one of the ways to do that is to use the distance. So I'm going to right click this and promote this to variable, and I'm going to call this snow thickness, and I'm going to make that visible in the editor, and I'm going to compile. And then when we go in here, we'll have a snow thickness value, and if we put this to say 10, then we get like thick snow. It looks kind of, let's maybe make it a bit lower, let's say 5. Now it looks really broken, so we need to fix that. So in order to fix that, the first thing is we are going to create some UVs. So to do that, what we're going to do is drag off here and go set mesh UVs, and we're going to use a box projection. And we're going to split the strut pin, and we're going to set the scale to the bounds. Split this, and then we're just basically going to take the maximum away from the minimum, which is going to give us the like overall size, and then we're going to put that into the scale. Now there's probably much better ways to do this, but that does work kind of. I mean, as I say, it's going to give you stretching and stuff, but for the sake of getting some UVs on the object, that works reasonably well, and we could obviously improve it massively. Then when we've got UVs, what we want to do is recompute the tangent like that, and we're going to compute tangents on our target mesh. Basically you'll notice this is getting daisy chained, so the target mesh is going in here, and then the target mesh is coming out of here. So this is the same as connecting this variable up like this, but it just saves you having to do that. You can just daisy chain them together. We don't really need to do anything with that. And then we want to do normals, and let's do compute split normals and see what that does. And we will set our angle to like 80 or something, so that it's basically going to just be smooth because it's kind of round, so we don't want, it's basically, this is kind of like, you know, when you have auto smooth and you set your angle, it's similar to that. And then we're going to compile this, and now we should be getting something that looks a lot more like snow. You can see the UVs aren't the best, but Cool, now just to help us visualize this a little bit more easily, I'm going to actually find a white material and apply it. But you'll notice that even though we've done the smoothing, there's still like some sort of jagginess to this. To improve this a little bit further, what we are going to do is do a smooth. Drag off here and go smooth, and then say apply iterative smoothing. And we're going to break the options out so we can see them, and we're going to put the number of iterations as a variable, so that we'll leave that as smooth iterations. So that just basically means we can have more or less smoothing. And I'm going to connect this up, and then I'm obviously going to connect this instead, otherwise we'd have the wrong one. And I also want to connect this in here, because when you smooth something, if you smooth it a lot, then it will change the bounding box size, so we need to make sure we connect that up also. And we compile, and now we're starting to get something that looks a little bit more like snow. And yeah, it looks kind of like cartoony stylized snow, but that is fine for now. So, oh, that's something I forgot to do. You need to actually expose the variable, otherwise it won't appear in the editor. So we'll compile that again, and now we have 10. So if you set this to like 50, you can see what it's doing. It's basically smoothing everything off nicely. So we go to 0, then it's quite sharp and edgy. Whereas if we go down to 5, then we start to smooth it off. If we go to 20, then we smooth it off even more, and that looks reasonably good. Then we can go up to our number of spheres and half that number. And you see we get something that's a bit less snowy. Or if we want it to be a lot more, we can put it to like 5,000. This will take a bit of time to calculate, so you've got to bear in mind the amount that you put in here, the speed that it will slow down, because it's doing lots and lots of raycasts now. So I'm going to lower this down to 1,000 again, because that is a reasonable amount. So in order to refresh that, I'm going to select the snow. I'm just going to increase the snow thickness slightly. And now you can see that we've made it a lot bigger, so we're getting a lot more holes. So potentially we might want to up this to like 2,000. And now we're getting a relatively snow-covered object. These little dimples are kind of annoying. There's lots of ways you could add more spheres, or you can increase the size of the snow. So if we make it like 6, then you can see that's taking most of those away. 7's always found as a reasonably good value for creating something that looks kind of snowish. We can space stuff out and then just regenerate the snow by turning that on and off. So you can see all the little spheres that are getting made, and then if we tick that again, it will generate the actual snow for those spheres. So basically after that, the last thing that we want to do is just add another sequence, and we just want to release all compute meshes. Adding this node just makes sure we clear all the meshes we're not using out of memory. So putting it at the end is usually a good idea. So that wraps up this basic version. In part 2, we'll expand on what we've created here, turning it from this into something more like this. This will involve making it a little bit faster and more efficient to use, as well as adding features like hidden layers of noise, textures and materials, and some additional snow-specific features. I hope you've enjoyed this tutorial, and I hope you can see that although this is used for snow, it could really be used for all sorts of things like moss, dirt, and other features like that. So thanks for watching, and hopefully I'll see you in the next video.